We're crazy.
Today's 29th.
Today is the 29th, yes.
Or 3 weeks left.
Isn't that insane? That's insane. We're over halfway through this semester. Okay. Beep. Will that work? Maybe. Yes. Good. All right. So, by the way, I normally start with questions from homework, but since it's a review day, just hold on to them. So a rational function. A traditional rational function would be something like this here. Can anyone tell me anything about what you would do if you had to graph this by hand?
You would simply factor
Besides
it
running out.
out. You would factor it out.
Yeah, okay, good. One very good algebraic thing to do would be to factor it. Now, why would that be a good thing to do?
Because it's simple.
Wait, I got you. You're good. Why would it be good to factor stuff? Because what do you need to know in order to graph a function? What are some good things to know? Intercepts. So what part of this function would relate to finding some kind of intercepts?
You said it was 0.
And when is a fraction equal to 0?
When
Can somebody give me a fraction whose value is 0?
0 over 3.
0 over 3. So when is a fraction equal to 0? When the top is 0. Good. And how can I tell when the top is 0? Well, it'll be easier to see if it's factored. Are you guys with me? So this is why, this is a very small example of this, but I really dislike when teachers, and I'm sometimes guilty of this too, makes things too recipe-ish instead of explaining why you do it. So factor it, great. Why? Why? What's the motivation? If you forgot to do it, what would tell you to do it? Well, I gotta know when the dumb thing's 0 so I can see what the x-intercepts are. Okay. Why would I factor the bottom? What would that relate to?
Asymptotes.
Yes, what kind of asymptotes?
Vertical.
Vertical asymptotes. Where are my students? What did I say about vertical asymptotes? What do we put there? What is a vertical asymptote? It's a
Line.
wall that we put, because the function cannot exist there. And I, in true geeky fashion, it's like, it's a trap, pull up. The shield generator will be quite operational. Okay, sorry. If you have no idea what that is, all about, you're fine. The values that make the bottom 0 are inputs I cannot use. They are where there can be no outputs. Most of the time, that's going to cause an asymptote to happen. Yes? Sometimes it might cause an open circle to happen. Does anyone know when that would happen?
Yeah.
You could factor the function such that in a factor form of it.
Yeah.
You can't go there.
If I could factor the top and the bottom and one factor cancels, that is still an input I can't use, but then it doesn't allow the function to go to infinity there. Because at that point, the top and bottom are lockstep. Neither one is overwhelming the other. Maybe you guys, does this sound at all familiar? This is straight from pre-calc. Most of you guys took this recently. Okay. All right, this is a particularly, let's just see. This is just a review, but then I'm curious about trying to attack this with calculus. If I factor the top, what do I get?
X plus 1, X minus 1.
That's insane. And if I factor the bottom,
X minus 5. No, X minus 2.
X
X,
minus
6
4
and 2.
times X.
No.
6 and 2 make 8.
4 and 3.
4 and 3 make 7. I like it. You're good. You're not in a game show. You don't have to. Took you too long. It's too bad. Does anything cancel? So how many vertical asymptotes will I have?
2.
And where exactly will they be?
4 and 3.
Be very specific.
X cannot be 3. And X cannot be 4.
So if I said what's the domain would be x can't be 4, x can't be 3. If I say where are the vertical asymptotes, that's the line x equals 4 and the line x equals 3. If you just say 4 and 3, that's wrong. I don't know what that shit that means. What does that mean? X equals 4. Okay, that's a vertical line. It's a vertical line. Okay. And obviously, what are my x-intercepts?
1 and negative 1.
Yeah. So it'll be 1, 0, negative 1, 0. All right, does this all feel familiar to you guys? Now, what we're going to bring into play, now obviously there's one more thing I could do here. Two more things. Y-intercept, does anyone see what the Y-intercept is?
1,
No?
0.
No?
0 is
Negative 6.
No? How do you find the Y-intercept? You make
X is 0.
if you cover all the X terms, what are you left with? 1 over what?
1 over 12.
Negative 1 over 12. So there you go. That's the Y-intercept. 0, comma, negative 112. How do you find the blank intercept? You make all the other letters 0. Right, I haven't told you about like one of my last classes I took, I had an equation that had 14 variables in it. And I had to find the W-intercept, so I just made all the other letters 0. That idea carries you through to graduate level shit and beyond. No matter how many dimensions you live in. So the Y-intercept, bam! Negative 112. Kick ass. What about the horizontal asymptote or totes? Are there any and what are they? And how do I tell? And this is a calculus idea that I stole from pre-calculus. So we're sort of like the snake eating its own tail right now.
There is one horizontal, and it's x squared divided by x squared, which is 1.
Good. What the horizontal asymptotes, where do they come from?
That.
Well, when the mama asymptote, no, shut up. Where do horizontal asymptotes come from?
The degrees.
Sorry?
The degrees.
Well, okay. Where do they come from?
The Y. I mean the Y.
Nope. When do they kick in? Let me ask it like that. When do they kick in? When do they need to be enforced? When do they matter?
There's a rational function.
No. When X gets really big. That's why in the middle it can cross it as many times as it wants to. Because all it needs to do is get close to it. It's the idea of a limit. It's exactly the idea of a limit. It is a limit. So the limit is X goes to infinity. So when we got to section 2.6, yes, the one about infinite limits, we brought back pre-calc ideas. Because horizontal asymptotes are limits at infinity. That's what they are. Okay, so the horizontal asymptote here, what situation am I in? The degrees are
The same.
In fact, let's do this. To get the horizontal asymptote, I let X get really big, positive or negative, but for rational functions, they both work the same way. Is this indeterminate?
No.
Sorry, I like only on Tuesdays. It's too bad. Forgot the third option. Because this is what over what?
Infinity over.
Yeah, it's in the form infinity over infinity. And I think when I show you the form of something, it sort of makes people think you can plug infinity in. Holy shit. I never want to see another 1 over infinity squared. I'm like, what? If you do that, again, I want you to bring infinity in the next day because you're telling me you can get there. You got there and you put it in. That's neat. Show me that shit. That's okay. If I die because I see it, at least I'll die having seen infinity. I'm okay with that. Sounds like a math person's dream. Are you guys at home with me? That's a little thing. Okay, if you do that, I'm going to be like, what the hell and whatever. Who cares? What can I use then? Since this is a ratio and it's in an indeterminate form.
Use a table.
We're way beyond tables. Yes?
What do you call it? The rule.
Where we're going. We don't need tables.
Derivative.
What can I use? What's a... remember old Greek dude? Well, now we have
The hospital.
medical dude. What is medical dude? Is he able to be used here?
Yeah.
His idea, not him. We'll have to go dig him up and whatever, but we can use his idea here, yes? Now listen, I am doing more than I have to right now. I want to make sure you understand. But I want to show you how the ideas of calculus will go back in time and make pre-calc valid, yes? There are other ways to do this problem, but we now know L'Hopital's rule. So what's L'Hopital's rule do to this?
You can.
What's the top become?
2x.
What's the bottom become?
2x minus 7.
It's still indeterminate, yes? So if I do one more L'Hopital's, what does this become?
2 over 2.
2 over 2, which is?
1.
That's insane. Okay, so that's the long ass way to do this. We can use pre-calculus and say, oh, the degrees are the same, so it's the ratio of the leading coefficients. But this is a nice thing that shows you, hey, we got the same answer with the calculus.
If the degree on the top was bigger or the degree on the bottom was bigger, would that mean there's no horizontal asymptote, or how would that
No,
change?
if the degree on the bottom is bigger, what's growing faster?
The bottom.
The bottom. So I'm dividing numbers by things that are getting faster, quicker. So when I'm dividing by bigger, 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 my answer gets,
Smaller, smaller, smaller.
and it goes to
Negative.
no. Again, negative infinity is really big. It's really big negative. My answers get small, really small. So what am I approaching?
0.
0. Good. Okay. Okay. What was I in the middle of? Oh, if the top had a higher power, that's what kind of sucks. I don't know if you guys remember this. It's called a slant asymptote or an oblique asymptote. You might have an example of one later.
When the top is bigger than the bottom, is that the y equals 0?
No, the bottom is bigger than the top. Like we just said, it'll go to 0.
Right.
Yeah.
But top is infinity? Or what is it? If the top degree is bigger than the bottom degree.
Then it goes to infinity
Right, yeah.
in a very prescribed way. How can you go to infinity? Does this go to infinity?
Yeah.
Yes, linearly. Does this go to infinity?
Yeah.
Yes, quadratically maybe, or whatever the shit, yes? Does this go to infinity?
Yeah.
Yes, square rootly. Do you guys understand? So if I say that's why slant asymptotes take the answer, oh my outputs go to infinity, and tells me how they go to infinity. Are they marching along in a straight line? Are they going like a parabola? Are they going like okay. Baby, you guys are, am I alright? Does any of this sound familiar? Now, some of this, of course, is new to us this semester, but it's old in terms of where we are today. We know how to do this shit. I don't have to do that. Again, just really make sure you understand. That was sort of a review of L'Hopital's. I don't have to do that shit. Same degree. This is 1, so the horizontal asymptote is y equals 1. Yes?
So in what type of scenario would the plausible be relevant over just looking at the hash values?
Do it again.
So like in what scenario would the plausible be necessary over just looking at the
Oh.
Huh?
If I had a graph a function that wasn't polynomial in parts, if it was a ratio but it wasn't polynomial, or it had a horizontal asymptote but it wasn't a rational function, you see what I'm saying? If I have a rational function that truly is rational, has polynomial over polynomial, I don't need L'Hopital's. Because then it's just a degree question. Does that make sense? If my function has a horizontal asymptote, but it's not a rational function, it's not a polynomial divided by a polynomial, and I can't step back and go, what's the degree? Then I need L'Hopital's help, potentially. Okay. Could you guys give me a rough sketch of this function?
Yeah.
Do it. Some of you guys are back there saying, I didn't say yeah. Oh well. Your spokesperson spoke. Do it. Do it. Let me see. Yeah, I made kind of an evil one because the two vertical asymptotes are really close, but I apparently don't care. We'll see what you guys think.
It's gonna be a square root function.
Yeah, because it's quadratic. No, it's quadratic function.
Oh, yeah.
So then look at you. So then put the y, write the y. The negative
And this is a moment where you just try, you got points, you can plot points, yes? You got vertical asymptote locations, you could put those in. Yes? If you have no idea what to do after that, at least do that much. Do what you can. Let's see how that is then. this.
So,
Oh, this is going to be kind of gross, yeah. I'm not going to do it on this one then. No.
I finished 3.
No,
I
no.
started 4 1. You have 10 sections of on the last this was I did like 7 on the last day, so I was pretty fine.
So if I just need a rough sketch of this.
Yeah. Oh, you did? And I had we went to the math students and then Justin just took pictures of all the show you.
did you have?
No.
This is probably the freakiest part of this question.
You just took pictures of everything. So
And I shouldn't have made this scale, but too bad I just did. Now, here's what's funny. I don't know if you guys remember this. Some of you guys just took pre-calc. In fact, a lot of you guys just took pre-calc last semester. Do you guys remember? I've got how many regions have I broken my coordinate plane up into?
1, 2, 3, 4, 5, 6, 7, 8.
Since this is a function, I've broken it into 3 parts. Look at this first part here. Where could the function be here? Where could it be? It could be here or here. Yes? So that's one region with 2 things it could be doing. Where could it be in this middle region here?
Yeah.
It could, to be honest, it could, I haven't plotted any intercepts yet. So in general, it could be here, it could be here, or it could be here, or it could be here, depending on if there's an intercept here. And we know there isn't, so it's going to come into play in a minute. Do you guys see there's 3 regions? Yes? Does this sound at all familiar? It's got to be a function, so it can't be up here and down there. There's one option for this region, there's one option for this region, and there's one option for this region. Where are my intercepts?
On the left side.
Yeah, we got x-intercept 1, 0, and negative 1, 0. Now that's interesting. What's my y-intercept?
Negative 1, 12.
Negative 1, 12. So it's going to be about right here. What should I do in this region here to figure out where this thing
Plug in 4.
is? There is no x-intercept between 3 and 4, correct? So I know it can't look cubish. It can't do this because there's nowhere for it to go through the x-axis. Are you guys with me? X-intercepts are doors that allow your function to go through. If there isn't one, it's got to exist on one side or the other. So I'm sorry, what'd you say? Go ahead. I think somebody said it.
Plug in 4.
No, plug in 4, the function goes crazy. We already know that. There's a wall at 4.
So we can find between
It'd be good. 3.5, that's crazy. So can somebody do that? Can somebody plug 3.5 into the function? Just plug it in. This is bread and butter math. This is graphing based on what I find, and then once I start to graph, getting what else I need. I need the value of 3.5. I can't graph this otherwise. And all that really matters is a positive or negative. But let's see. Blah, blah, blah. Nine forces 10, force 11, and 4. Divided by half of 1.5.75. 4/3 of 45 force. Is that 15? What do you guys get?
Yeah.
I think it's 45.
Negative 45? I'm cool with it. I'm trying to do it in my head. Not the easiest thing. Yeah, negative 45? Is that what everybody got? So then it's way the shit down here. Yes? My scale sucks, but that's okay. How do I know it's got to do like a little parabola? Because,
It's gonna be facing down.
well, it can't go up because it can't get through the x-axis. Okay. Do you see, now, we're not going to do calculus to this function because this is a little bit worse than I'd want it to be. But do you see how using calculus I could actually get stuff like concavity and know exactly what the shape of it is in here? If I did a second derivative to this thing, which we could do, it wouldn't be easy to figure it out though. I could see what kind of concavity it would have down here. What about over here? Can anyone tell if I just wanted a rough sketch of this? Can you guys see how you could draw where this thing is? I don't know if you guys are with me. Could it be down here? It's got to be up here or down here, correct? It's got to run up against those walls. That's the beautiful thing about having asymptotes, is it constrains what your function can do. There's only two things you can do. Which one of those does it have to do? It must do one thing. Are there any x-intercepts anywhere else? Have I plotted all the x-intercepts?
Yes.
So if the function lived down here, what would it need to do?
Can't cross.
It would eventually have to cross. Is it allowed to?
No.
No. So where is it?
Down.
Here. It can't be down because then it would have to go through the x-axis. Do you guys get that? Now, if I plugged 5 into the function, I can get very specifically where it is, yes? But I just want a rough sketch. Okay. Now over here, look at this freakiness. I love it. Gaze upon this freakiness. Love this shit. Now here's what happens with this.
Sure.
Let me see if you guys are cool with this. This is where multiplicity becomes really helpful. So I mean, what could this thing do? It could do this maybe, and it's got to go up here, yes? Or it could be up here and bounce, and then no, it can't bounce though because it's got to go here. I mean, so it's very constrained. But let me see if you guys are cool with this. I could plug a 2 in and see where it is. But over here, it's either got to go up against that wall or it's got to go down against that wall, yes? It's got no other choice in that direction. It's got to go all up forever or down forever. Over here, it's got to approach that. It has to. Yes? This is just what's going on in the middle and which way does it go. Okay. I could plug a 2 in and see where it is, and that would answer that question. The multiplicity of each one of these is what? How many times did 1 show up as a root? Once, so it's multiplicity odd.
Goes through.
And a line goes through. So since it has to go through both of these, and it has to be here, it's got to go through this, and it's got to go through this. Now that is a funky ass graph. I love it. Yes.
If there wasn't the horizontal asymptote, then it would have just been a parabola, right?
No, it can cross the horizontal asymptote.
Oh, if the horizontal asymptote wasn't here,
Yeah.
then it would have to be. That would really fundamentally change this, though. That would be a completely different function. So, yeah. You see what I mean? Yeah. But you're right. There would be no reason for it to kind of like level out. Yeah. How you guys doing? You guys all right? Does this sound familiar? Do you see how there's concavities happening? What concavity does it look like I assumed was happening here?
Positive.
Yeah, concave up, and it looks like I assume somewhere over here it becomes concave down, yes? And you guys did this in pre-calc. Very often your concavity was correct, but you weren't thinking about it because you didn't know what the shit concavity was, but it's just kind of like what made sense from what their function seemed to want to do. But now we can come with calculus and figure out, is our concavity correct? Maybe some of our assumptions are wrong as shit.
Would you be able, after you've done this section, would you be able to give us a practice problem test that relates to the bar graph, like the concavity? When we're doing the math review, like the review for testimony?
Sure. In fact, I have one, but it's about a rational function, but it does bring concavity in.
Yeah.
If that's what you're saying, okay. All right, so what I really wanted to do with this is to review, where do the asymptotes come from? How do I work with a rational function? How do I get the intercepts? Blah, blah, blah. Yes? So now we're going to bring calculus into this. So let me go ahead and give you this. We're doing the side that doesn't have the little
I lost 5 points.
stoplight. It's got nothing
I
but
lost 10 points.
black and white.
I didn't put like the units. I didn't put in the inches.
You'll see what I mean when you get there. We're doing the side and giving to you based
I
on.
lost 10 points because of that. And then this one I just didn't understand. I lost 12 points on this. How'd you get?
I don't know, maybe that's the same. If I got a 62 on this, I don't know, everything I can do competition.
Yeah.
Very easy. Word problems?
The word problems were hard.
I know for me, if you show me the same exact word problem, the one you did on to show me to a competition.
And I have a struggle with proofs, like with
So can you guys
grade when we did like proofs.
do A through F?
I struggled with that so much.
Well, A through G.
Sometimes you just get it.
And then I'm going to help you with the asymptotes because some of you guys might realize what situation we're in. You might need a review on how to get it. But the first part of this is just, well, B is starting with calculus. A is not calculus. So do as much of A through G as you can. You can work with people near you if you want to. You can leave your friends behind. They are no friends of mine. So that will be yeah. Check. The biggest mistake to make on the derivative is to forget that that negative's got to distribute. Negatives always find a way. They're sort of like nature. They just find a way.
It would be negative 2x squared minus 60.
Yep, right there.
Okay.
And that's why you get that minus 4 in the middle. Okay. And that's, again, that's why I tell you what it's supposed to be. So even if you can't get the derivative to work out, you can still do the rest of the problem. What'd you guys get for the critical numbers?
1, 4, and negative.
Yeah, because the top you can factor. Right, this becomes, just look at the top. So the two things that make it 0 are 4 and negative 2. And the one thing that makes it undefined is 1. So remember, critical numbers, again, most of the problems we look at, you make it 0 because it can't be undefined. And then your brain sort of forgets, oh yeah, critical numbers are where it's undefined also. It's everywhere that it could go from increasing to decreasing. So look at this function, is it increasing? Yes, and there's an asymptote here. Now what's the function doing on the other side of it? Holy shit. So a place where it's undefined could still be a place where it changes its direction. So it's still a critical number. It's still, I'm trying to identify everywhere where the slope can change from positive to negative or vice versa. And I think we should have hopefully gotten to this point where you started making this thing. And again, this is where multiplicities really help out a ton. Yes?
So we get 4 and negative 2 just by factoring, right?
Yeah, we factor the top. So 4 and negative 2 make this 0, and 1 makes it undefined. So those are my critical numbers. I like it. So here I'm going to put Z, U, Z. And again, everything I try to get you to do is just helping you out. It's not like I'm requiring you to put Z's and U's. It's helping you remember what the shit's going on. Every single element. Well, the top 2 elements are a first degree, so multiplicity 1, and the bottom is a second degree. What does that mean? It's going to stay the same sign on either side of 1, and it's going to change signs on either side of negative 2 and 4. Now again, if you don't like that at all, if you forgot it and you don't want to remember it, and you hate multiplicities, okay. But here's the power of them. If I put a 0 in, I get a negative answer. I don't know why I said answer like that, but I'll be okay. So when I get a 0 in, I get a negative answer. I just said it stays the same sign on either side of 1 and changes signs on either side of the other ones. I'm done. Look at that shit. I made my sign diagram. Bam. Now, if you don't like that, plug in 5, plug in 3, plug in negative 17 trillion, whatever the shit, right? That doesn't take that much longer, so that's fine. Did anybody else get that same sign stuff? Okay. All right, keep going, keep going. Pretty sure most of you guys got to this point at least. Just want to make sure you guys know, if you got this, you're on the right track. If you didn't get this, let me know if you need help figuring out what went wrong.
Well, it's not well, what? It was like 12 was the answer.
The 36 divided by 3.
Yes, yeah, totally.
Much simpler way to do this.
Let me make sure I'll go do math again. 4 squared, 16.
So you can see where it's increasing, decreasing really easily.
32.
Is there a maximum?
Yeah. Local.
Yep. Is there a local max? That's all I asked for. So yeah, is there a local max?
Yeah.
Where?
Negative 2.
And min?
4.
And of course, we can see that here.
32.
Going up, coming down, going down, going up. At 1, it's doing weird shit. So
32 plus 64 is 96.
how do I finish those points out? How do I get the other
Put it on the test.
after those points?
Yeah, just plug it in. You don't have to do your thing.
Plug it in where?
The original.
Original, good. His job is to make points. If you ever need a point, that's his job. That's your go-to man. I got a point man. You need a point, go to this guy. So if I plug a negative 2 in, oh my god, what do I get? Negative 24 over, do I get 8? No. Yes. Do I get 8? Did anyone do that? Yes? Okay. I don't trust my own brain anymore. When I plug a 4 in, what do I get? I get 80 over 3. Do I get 80 thirds?
You get 90. It'd be 96 divided by 3. So you get
Oh
90.
boy, I did that wrong. What did I do? I did that too quickly. I don't know what I did.
It would be
32 plus
64.
64.
It would be 96
Yes, 96.
divided by 3. 32.
Oh, nice. Okay. Thank you.
We're struggling with it. We're doing the same thing. Let me just use
Is that okay? Is everybody
Yeah.
with me on that? Obviously, 1 was not ever really a candidate. So I really want to make sure you understand. We have to put 1 here because it is possible for the slope to change signs on either side of it. Yes? I was showing somebody, here's an asymptote. This slope is positive, now it's negative. There you go. So I have to put that on my sign diagram. But it can't be a max or a min because it's not even part of the function. There's no point there. Okay. This one I think was probably, this one probably is where a lot of you guys are right now because you didn't let it go like I suggested. But all right, look, this is the kind of problem where you just have to sink your teeth into it. And part of your brain should love this because it's just algebra. It's not heavy conceptually. You just brute force the damn thing, yes? Now the first step is calculus, I know. But the hard part is the algebra. So if I start here, and I take the second derivative, I have to, of course, use... so a derivative of the top times the bottom minus the top, times the derivative of the bottom. Chain rule doesn't do anything really because the derivative of the inside is 1, yes? And the power is 1 now because it went down by 1. All over x minus 1 squared. Now, real quick. Can I kill these two? There, die.
No.
Die. Why not?
Well, because it says.
Because this one's also being divided. But, do you guys see? Oh, this should be a fourth power, by the way. This has got to be squared. So this will be a fourth power.
So if the negative or the minus never existed.
So if they're both being divided by 4x minus 1s, do they both have x minus 1s?
Yes.
How many x minus 1s do they both have?
For one.
1. So I can kill 1 x minus 1. Do you guys see why it's important to check? Anytime you have a division, before you start multiplying shit out, it's already factored. So just go, does any factor cancel? And now I got less shit to multiply out, thank the gods. Are you guys understanding what I'm saying? Maybe? So this idea about simplify the function before you attack it with calculus, you could actually expand on that. Simplify the function before you do any damn thing. Yes?
So you can only do that if it's being multiplied by another number.
Well, I could factor 1x minus 1 out. Yes? And then division would cancel that multiplication. So the shortcut is whatever they share, I can cancel that many of them. Because now this guy can't have any more canceled, so I can't divide both of them by any of these. When I have a fraction, that element is being divided by this, and this element is also being divided by this. I can't
because
have
they won't
one of
have
them
the same
change
thing.
differently than the other one does. Okay, maybe. I know our brain says, oh, it'd be so much easier if I just did this. You're like, great brain. It's a quick way to get the wrong answer. Let's not do that shit. So now I got to simplify this insane thing. Do you guys see now the bottom is the same as it's supposed to be?
Yeah.
By the way, some of the hardest problems I've ever done as a student have been show this is true. Because your brain tries to make it look like this too early. It is not going to look like this at all. For a little while, we're kind of lucky that the bottom looks the way it's supposed to already. The top don't look anything like it's supposed to yet. So see, if I distribute this crap out, what do I get? I get 4x squared minus 8x plus 4. And then this 2 just distributes, the negative distributes. These die, these die, these combine. There's the 36. You guys see that? That should be, sink your teeth into it if you are just kind to yourself. More kind to yourself than mine, because this is a little bit gross. I might lose track of what happened. But if you're nice to yourself and you really slow down, you do every step, you can sink your teeth completely into this thing. Some calculus shit, there's nothing to sink your teeth into. You're like, oh God, here we go. You know. So please, this is work, but it's relatively straightforward work. Okay. What's my critical number then for the second derivative?
X equals 1.
And then when I make a sign diagram, just not a lot going on. Thank you, problem. Obviously, the sign is totally determined by the bottom. When I plug a negative number, the bottom is negative, so the whole thing's negative. When I plug a positive number, positive. So here's the interesting question for you. Is there an inflection point? Because the only input that there could be one at is not even in the domain. So let me ask this again. Is there an inflection point? No. Because an input of 1 has no output. Is there a number around which the concavity changes? Yes. Yes. But why is there no inflection point? Because this input does not make a point. I need you to see that. That's why even critical numbers that make it undefined, I must still consider them because the sign could change around them. What's this concavity?
Positive.
What's this concavity?
Negative.
Holy shit, so around an asymptote, do you see the asymptote in the middle? Around an asymptote, can the concavity change?
Yeah.
Yes, so I must plot it on my sign diagram so I can investigate.
But
Does it lead to an inflection point?
no.
No, because there's no point that it can make there. Okay.
So the real answer to that is no inflection point.
There's no inflection point just because an input of 1 does not make a point. Do you guys get that? Does the concavity change around 1? Yes. Is 1 the location of an inflection point? No. Okay, maybe. Screw you, Jeff. All right, I'll be okay. Where's this concave? Screw it. Concave down up to 1, concave up 1 to blah, blah. Yes? No inflection points. Just because I can't complete this. Yeah, it would be undefined. So it's concave down back here, concave up there. Did anyone find the intercepts?
Yeah, you factor out 2x, so
Yeah, so the top
x plus 8,
becomes 2x, x plus 8. So what are my x-intercepts?
0 and
negative.
So what is my y-intercept?
0.
Yeah, 0, 0. Okay. You guys with me? So you get 2 x-intercepts. Asymptotes is where things get freaky. What situation are we in terms of like a limit that leads to an asymptote, horizontal asymptote? Which degree is higher? Top. So obviously this goes to infinity. So the question isn't what is the limit. The question is what does the function look like as it goes to infinity? Yes? Now really quick, let me see if you guys are cool with this. What's the limit as x goes to negative infinity? Negative infinity. What's a negative number squared? And what's a negative number minus 1? So as it goes to negative infinity, my inputs go, it's positive over negative, so it's going to be negative infinity. So at the ends, it's going to look like this. Now that's a silly, does anyone remember how to get the slant asymptote? Or your teacher might have called it oblique asymptote. Oblique mathematics, what dost thou want?
It's when the top is bigger than the bottom.
I always loved oblique, it just sounds like the beginning of Shakespearean thing. Okay, go ahead.
Isn't it when the top degree is bigger than the bottom?
That is when it happens, how do you find it? How do you find it?
You plug in a 0.
You're like,
You plug in a 0.
long divide or
Oh, synthetic degree.
synthetic. Can I use synthetic on this one?
Yeah, you can.
Do you guys remember how synthetic division works?
No.
It'd be plus 1 as the low box thing.
Yeah.
And it'd be 2 and 16 and then 0.
Because there's no
Bring
constant.
Bring down the 2.
Now, real quick, sorry. Does this look completely foreign to anybody?
No.
Be honest. Has anyone never seen this shit before?
I remember.
Because I could do long division, yes?
No, like
This is a shortcut. No one likes long. So let's see, you bring the
2 down.
2 down.
2 times 1
2
is
times 2 is 2.
That's crazy.
2 is 18.
18.
18 times. And that's the remainder.
So then the answer would be
2x plus 18 plus 1 over 18.
now, real quick, 2 things. If you forgot how to synthetically or long divide, oh shit, you might want to focus on that just a little bit. Not over prioritize it, but
Why do we get the 1? Just double checking the 1.
here?
Yeah.
Oh, very quick. If I wanted to long divide, the nice thing about long division, and I'm going to answer your question in a very roundabout way. The nice thing about long division is it works the exact same way as numbers do. X times what is 2x squared? 2x times x is 2x squared. 2x times negative 1 is negative 2x. What do I do in long division next?
Cancel.
Subtract. And of course, subtract just means change the signs. So over here, what we did is we lose the x's. The x's don't matter. What's going to happen here? Cancel. So I want to develop a process where I don't even write this stupid thing because it's always going to cancel. I'm just wasting time writing this because it was going to cancel. All I care about is right here. What's 16 plus 2?
18x.
And you see 16 plus 2 is 18? So this is just a shortcut to long division. That's what synthetic division is. Why is that a positive one? Well, I got rid of the x, and then I said, let's change the sign from the beginning instead of each time. Each time I would have to change the sign.
Okay.
So here it would be plus 18, 18x minus 18, change the sign. So instead of doing that every damn time, we just decided, I'm going to put a positive one, change the sign at the beginning.
And if it were to be a positive one in the bracket?
If it was x plus 1, then this would be a negative 1.
Okay.
Change the sign. Yeah. So instead of changing it every damn time, change it once.
Okay, awesome.
That's why synthetic kicks so much ass. So what was the idea of a horizontal asymptote? Is effectively the limit as x goes to infinity or negative infinity. So what is the limit as x goes to infinity of this? Don't overthink it. Don't overthink it. What happens to this guy? As x gets really big
It gets really small.
and goes to 0. So what's the limit? 2x plus 18. So this function is going to look like 2x plus 18 at the ends. In the middle, it's going to do all kinds of weird shit. But at the ends, it's going to follow 2x plus 18. You guys look appropriately excited about this. So the slant asymptote is 2x, y equals 2x plus 18. It's got no y-intercept. It's got these two x-intercepts, no inflection points. So let's see what we can do. What kind of scale do I want on my y-axis? Because what do we have to get up to on the y-axis? Well, we got to get to 18 for the y-intercept for this guy. But we got to get to 32 for this guy. Yes? So I can go by 4 wouldn't be enough.
8.
Because I would need 8 tick marks. If I go by 8, that would work. 10 would work fine too. So I'm going to do 8s just because. There's 32, yeah? Yay! That's plenty. What do I want my x-axis scale to be? So I need x's of negative
4.
2, 4. I need an x of negative 8, yes?
What about -2?
Or either 4 or 2.
I'll go by 2s, right? You never want to make your scale much bigger than it needs to be. Because then you're kind of like compressing your graph and it makes it harder to sketch. Is everybody semi with me? If I look at all the points I have to plot and I just look, what's the biggest x's? Okay, that tells me what my x scale, what's the biggest y's? Okay, that tells me what my y scale wants to be, yeah? So then I'll go by 2s. Okay, so let's see what we got. I got an intercept at 0, 0, and negative 8, 0. I have vertical asymptotes. Where'd they go? Oh yeah, that's right. We haven't really officially. What's the vertical asymptote? I forgot this is where I said asymptotes. Yeah, this one's nice. X equals 1. So I have a vertical asymptote at x equal 1. Whee! Horizontal asymptote's not there. It's a slant asymptote. So if I graph that, all right. How's everybody feeling right now? You guys okay? I love you guys. So 2x plus 18. I'm going to try to graph that. So it'll kind of go here. Yes, and then it's going to go up 2 over 1. And if I'm nice to myself, let's see if you guys are cool with this. So that would be up if I go up 8 to 24, I would go over 4. I don't know, let me make sure you guys are cool with that. If I go up 2 over 1, that means if I go up 8, I go over 4, yes? And why am I doing that? So I can kind of like hit the scale again. Up 8 over 4. Bam. I should have made that an open circle because this is a asymptote. Oh, that's one of the best lines I ever drew in my life. Holy shit. Doesn't take much. Now, holy shit. What really kind of sucks there, oh, that's right, I gotta be careful. I definitely need to make this an open circle so I don't suddenly think that it's a point on my graph. Okay. So do you guys see how, let me see if you guys can see this. Nothing changes even though that's diagonal now. I could be here or I could be down here. Now we already know where it is. How do I know which one? It could either be in here or down here.
It's got to be done. Where the
Because we have a little.
Why can it not be here? There's no x-intercept, yes? Do you guys see that? Now, let's go through this carefully. Here's an x-intercept here, yes? Did we get a max? I haven't plotted those yet. -2, 8 is a max. Yes?
Yeah.
And 432 is a min. Is that right? Yes. That is incredibly useful information. So I've got to go through now. Can you already see how this thing is gonna move?
Yeah.
It's got to slam up against this wall. It's not going to come this way because then how could it get over to there? So it's got to go through this wall. That's a maximum. Then it's got to go through 8, and then it's got to follow this. I mean, everything I've already got is enough information. I don't know if you guys see this. It's got to do this. It's got to go through there. That's a maximum. What's my concavity through? Oh, I didn't have any inflection points. My concavity is down. Yes?
Yeah.
Down concavity. Down concavity. And then I follow this line. And then over here, I'm an up concavity. I've got to follow this line, go through that point, and then follow this line. So that's my min right there. Neato. Whatever you say, John.
How'd you find this line test?
Divide.
What divide over?
Divide what the original problem wants me to do. What does this problem want me to do? What's the main operation? Division. So then I just do it.
Oh.
Divide 2x squared plus 16x
Oh,
by
yeah,
x minus 1.
synthetic
That's the long division or the synthetic division.
Yeah.
Okay. And then you plot this in the calculator, see if you got close. Great. All right. Does any of that feel familiar to anybody? If not, does most of that make some kind of sense? Now, obviously, if you're really disconnected and you have other things that you're really not understanding, especially if they're like derivative rules, those are more important because this would be one problem that you could probably do a decent chunk of it. I'm just talking from your perspective as far as what's a setup. You guys with me? If you understand everything else and you forgot slight tests, well, then do examples of those. Make sure you get that problem totally right if I give you one of those. Yes. Okay. That concludes all the way up to 4, 5. So now I'm going to open it up. And what I want you to do, actually, before I forget, I've done something like this before, but never really with these little lights. So all right, look, can we just talk let's just talk about the fact that I'm a person trying to make all of this make sense. Yes? You understand what I'm saying? I'm not some mythical creature that came from somewhere, just a dude that knows some math and wants you guys to know it too. This is my attempt at helping you remember the ideas you're supposed to know, and gauge yourself in how well you know, so then you can maybe ask better questions in terms of what to kind of go over. Can you guys take a minute? What I want you to do, for example, implicit differentiation. How many guys feel really confident about implicit differentiation? Anybody? If anybody is, you would circle the green light. Yes? Green, go. If you're, you want a little bit of review, then you circle the yellow light. If you're like, I still don't understand what the shit, then circle the red. Yes? In the first box, I want you to write anything you remember about it. In the second box, I want you to write questions you still have. Are you guys with it? You can do as much or as little with this as you want to. If you're totally disinterested in this, you can do some problems from the practice test. Yes? Again, I want today to be as useful as possible. If more of you kind of consider this for a little bit, you might kind of organize your own thoughts better. Go ahead and try to fill this out for me. Put as much as little down as you want to. Go ahead and try to do this for me. If you're not sure how it works, call me over. I haven't been recording here in a while. Forgot to turn it back on. Rawr. If you're at home, I'm sorry. We did this problem. You can pause if you want to. This was me showing why the secondary test is sometimes inconclusive. Yeah, okay. Shoot. Forgot to turn it back on the last time we paused. Okay. Anything else? Look at real quick. 1C. Do you guys see how that's an example of what we just did? What could I do? Do you want to do a chain rule with this? What could you do instead? Is the inside raised to a power? So what can I do with the power? Bring it down. I don't give the first shit. So natural log of 3 to something. That can always come down. That's the property of logs. There's an idea I've been playing with, because I say stuff like the process doesn't care. Right? If I have x to a power times x to a power, add the powers. The process doesn't care if they're fractions. The process doesn't care if they're variables. You add them. So there's an idea of structure, and the structure doesn't change. The specific things that are in the structure changes, but what I want to find is what's the structure that tells me what rule to use, for example. So I'm thinking about trying to create some lessons around that, but we'll see. I already sort of teach that way, but not explicitly. This is an example like, what was I doing here? I forgot. Oh yeah, this is me trying to mess with the other way. Okay, this is an example of the logarithmic differentiation. There's this one, remember? You got to know what's the derivative of just inverse tangent of x?
1 over 1 plus x.
Good. So then that's an example of knowing the rule for a function, but incorporating chain rule into it also, right? So yeah, if you try the practice test, and any other ones that give you a lot of trouble, or if you haven't tried it and you're looking at it and you're like, I don't even know how to start that one.
Put that second part 5%.
Oh, if we're all drive, nobody else has any questions, I'll do that one. But does anyone else have any other questions? If not, I'll just do that one. Okay, all right. So this one I made, if I remember correctly, I made this a little worse than I wanted to. Do you see how we were like 0.0005 away? And I'm curious, well, what if I allowed myself to be off by 0.01? How far away could I go? So here's the idea. I want, let me see if you guys are cool with this. I want the difference between my function and the correct value. How do I want to, let me see, oh, here we go. Natural log. I want the difference between the function and the correct value to be less than 0.01. And the function, I gotta be careful, not the function, but the linearization. That's the one I want. I want the difference between the linearization at -2 and the function at -2. I want it to be less than 0.01. Not -2, Jeff. That's what you're doing. I want this, not -2, just in general. I want to know how far away can I get to let this be true. The value of the approximation minus the actual output of the function. I want them to be this close. Okay. So when we got 0.03 away from the input, we were 0.0005 away from the output. So if I give myself more room to live, how close do I have to be now? So the only way to do this really is in your calculator. So if I put in here, what was my linearization? It was, where'd it go? X plus 2. And my function was natural log of x plus 3. I want that to be less than 0.01. So I want negative 0.01 to be less than x plus 2 minus natural log of x plus 3 to be less than 0.01. So I want to be within 0.01. I could have written this the other way. That might have been better. Let me think. That would have been better, yeah. That's too bad, Jeff. Let me see if you guys are cool with this. Are you guys cool with this? I could have written this the other way around. That would have made this a little bit better. Switch those two. Let me do it that way. You'll see why in a minute. So if I add x plus 2 to both sides, I'll get x plus 1.9, I'm sorry, 1.99. Let me make sure you guys are with me. If I add x plus 2 to both sides, this will be x plus 1.99 is less than this, is less than x plus 2.01. This is all incredibly fascinating. They do examples in the book of this. I did not bring calculator, so I'm gonna shoot over to Desmos real quick. So what's neat is, if I put into Desmos, let's see, my floor, my function, was it that one? Yeah. And my ceiling, and I'm zoomed way the hell in, there we go. I'm at -2. Do you see the green line? That's my function. Now, I want to be this close to the actual answer. Do you see how the actual value is not that close if I go too far away? So this picture is showing me very colorfully the idea that I spoke of before. If I get too far away from the number I built into it, my approximation gets too far away from the actual answer. So in your calculator, you have to find the intersection between those two. In Desmos, it's easy. It just does it for me. So it would be from -2.13 to -1.85. That would be the interval of inputs that would keep me to within 0.01. There you go. See, that's how you do it. So it should feel a little bit like section 2.4, where my box that I was trying to kind of get into is kind of shifted over now. And I get close enough starting here, and then close and close and close, and then I lose it there. It goes away, too far away. So I just say from where I enter to where I exit. That's it. Some of you guys are looking at me like, are you going to start explaining it now? I did. I don't know what else to say. That's how you do it. Just to show you. So obviously I'm not going to make a big deal out of that. This was section 310, right? Yes. So here's an example of the idea. Oh shit. Love you guys. I think they get more specific. Do they? Maybe that is a specific place. Here. That's the function plus 0.5, that's the function minus 0.5. I think I just did it backwards. Yeah, I did, didn't I? That's okay, it still works the same way. All right. That's not going to be a focus of mine. So I'm not going to focus any more time on that. Anything else we didn't cover that you want to talk about? Could be from the practice test. Nobody wanted to say a word about these. And maybe it's because we've done enough of these that you feel like you can pretty much just attack this kind of problem. Yes, maybe. Is that true? Okay. Well, I think you guys are shaking it, yes.
Can you do 10B? I just want to see because it's not flashing. So I just want to
It's what now?
10B.
10b. Oh, how do you very quickly make that a fraction?
So like you're gonna put the e to the negative x squared and we just add like a minus.
And do what?
So you're gonna put the e to the negative x squared and the bottom and like add like a negative.
It already has a negative.
So we're gonna make it a positive.
What's a negative power mean?
It's on the bottom.
Flip. So when I flip it, it's not negative anymore. So it's kind of like a built-in. It's already a fraction. Yeah.
So then we're gonna
Then you just attack this with L'Hopital's because now if you investigate it, it's indeterminate. It's infinity over infinity is that form. Yes. Okay. So then L'Hopital's will work. Yeah. The ones that are trickier is when I have like x times natural log of x, and you have to take x and make it 1 over x on the bottom. So you have to force it to be somewhere it doesn't want to be. This one, what did it want to do from the beginning? It wanted to flip down, so then you let it, and then suddenly L'Hopital's works because now I have a ratio. Okay. Maybe.
do you like tell us to like use L'Hopital's rule or like
Sorry.
do you like write like for this problem use L'Hopital's rule or we have to know that?
Understand.
Like
Why can I use L'Hopital's rule
No, I
here?
was like so for number 10 you said like solve it like using the hospital rules, right? So you're gonna tell us like for this
Where
one-
appropriate? Is it appropriate in every single one of these problems?
Yeah, but
Is it?
No,
Is it appropriate in every one of these problems? Apparently I'm saying no it isn't. Which problem can I not use L'Hopital's rule on?
for B, right?
No, B is beautiful. Why can I use L'Hopital's? Two
Oh,
things.
yeah,
It's a
but-
ratio
Yeah, but first.
and it's indeterminate, yes? What about this one? Is it a ratio? Is it a ratio?
I guess yeah.
No guessing. Of course it is. Yes? It's got a top and a bottom. Is it indeterminate? What's natural log of 1?
Just
0. What's tangent of 0? 0. Is that indeterminate?
Yeah.
So L'Hopital's rule works here, L'Hopital's rule works here. So apparently it won't work here. Why not?
It's not 0 on the bottom.
It's not indeterminate. It's 2 on the bottom. So you know me. You have met me. You've been in the same room with me for 3 weeks. And you know I'm going to give you a limit problem where you just plug the damn thing in. This is one of them. If you just plug a 2 and you get the answer, you're done. You don't have to factor. You don't have to L'Hopital. You don't have to do any of that shit. Because the bottom is 2. Therefore, it must be determinate, which means I can determine the answer right now. That's what that means. If it's indeterminate, oh shit, I gotta do something to determine the answer. If it's not indeterminate, I can determine the answer. So that'll be 0.
Looking at this, it says linear approximation and differentials.
Differentials is dy and delta y. dy equals f prime of x dx. Yes. Again, it's not a really huge focus of mine.
What about roles?
Rolle's theorem is mean value theorem where the outputs are the same, so then your slope ends up being 0.
And that's the only extra, like, parameter, like, the need to be met in order for it to be used.
Personally, I wish we want to give them prompts, but it makes students more confused. So I'm like, all right, what matters more? Students not being confused. Everything is mean value theorem. Even Rolle's theorem is mean value theorem. It's just that our rise over run comes out to be 0. So it's still mean value theorem. It's just I set the derivative equal to 0. Yeah. So if I have 2 points that are crossing each other, when will the tangent line? Well, when the tangent line is horizontal, they'll have the same, which means it makes it equal to 0. So I do dislike that we make it feel like it's its own separate thing. It isn't. It's the same thing. They require continuous and differentiable functions. So if you have a question from the quiz, if you have a question from the practice test homework, if you don't have any more questions, then you're ready. I just leave the quiz test right now. I'm not good.
If you could set up one more related to this question.
Sure. You got a specific one or no?
One, I imagine, one that would be similar to the on the test.
Which again, could be any of the ones I assigned or didn't assign. So, yeah. I don't know. Let's see. Blah 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 blah. Oh. What about number 17? All right. 2 cars start moving from the same point. We'll travel south at 60 miles an hour. And the other travels west at 25 miles an hour. At what rate is the distance between the cars increasing 2 hours later? So if you drew that picture and you indicated variables for everything that's changing over time, is anyone playing along that's done that? I just did it. So let's see how similar ours are. You got somebody traveling south, somebody traveling west, and the distance between your inch. So all of those are changing over time. The snapshot is 2 hours. Now, what else did they tell me? I closed the damn book. They told me how fast each one was going, right? How fast did the westward going dude traveling?
24 miles.
And the southward going dude?
60.
Okay. Okay. So then what's the relationship between... Yeah. So the big deal is, what do I do on every related rates problem? Draw a picture if it makes sense. Label everything that's changing with its own variable. Label anything that's constant with its value. Step back, what's the relationship? If I can get the variables to be related, I can then take a derivative and get the derivatives to be related. And then I can plug the information that I know and solve for what I don't know. So in this case, what's the symbol for what they're asking me?
The rate of changes.
Yeah, so dz dt. So yeah, you set up the Pythagorean theorem, you take a derivative. Yes? When does this come into play?
For finding the x and y values when you actually plug it in.
Yeah, after you've taken a derivative. Yes? So this would be x squared plus y squared equals z squared. So 2x dx dt plus 2y dy dt equals 2z dz dt. All the 2's can die. Can somebody tell me what's the value of x 2 hours later? Don't think too much. 50, yeah. And dx dt is 25. What's the value of y 2 hours later? 120. What's the value of z 2 hours later? Now I need a little bit of help, right? Not too much help, because this is, I don't know, let me see if you guys are cool with this. At the snapshot, this is 50. This is 120. Does anyone remember 512 something? 512, 13. So 50, 120, 130. So z is 130, and dz dt is what I'm trying to solve for. And then you just got stupid algebra, yes? Not stupid algebra, but just algebra. Multiply, add, divide, yeah. Now, the way that the formulas and so forth are created and all that changes from problem to problem. But what is kind of the recipe? You almost always draw a picture. Label what's changing with variables. Label what's constant with numbers. Write in symbols what they tell me and what they ask me. And then what's the relationship between the variables? Now, some problems are really straightforward, where they give me like the volume of a snowball over time. So the formula already exists. I just got to take a derivative and plug in what they tell me. Yes? Okay. Does it be 172? I don't know. Anything else we want to focus on? You guys can all get your quiz corrected by tomorrow. Okay.
What are the units for that given to be miles per hour squared? Or would it, look, is this already in terms of, like, everything's already in the same terms of what we need. So that's why it was 2 miles per hour. It's not asking for acceleration, it's asking for.
Yeah, and if you look at the units real quick, this would be miles times miles per hour, yes? And that's miles times miles, but you're going to divide by miles. So this will cancel and your answer will be miles per hour. So you can always do what's called unit analysis, but if you feel really good that you set everything up correctly, you can literally just put the units for what each of these are. And of course that's the distance in miles and that's the time in hours. Yep, cool.
What would unit analysis look like?
Unit analysis is what I just did. That's what I just did. I analyzed the units of each piece. Each of these looks like miles times miles per hour, yes? Miles times miles per hour. Miles times miles per hour. But I'm about to divide by miles. That will cancel miles per hour. Yeah. And there was a problem on my master's in physics candidacy exam where I had no idea what to do. And they just made the units work. And the teachers later were like, hey, good job on that problem, John. I didn't know what the equation was. I just made the units work. But I did tell them, like, of course, you don't got that shit. Anyway, so unit analysis can save your ass. If you forget anything else, you can make the units work. Yes. Obviously, this is a little harder because you got to make the formula out of derivatives. So, but once you're there, you can make the integral. Anything else? You guys can head out if you're ready. You guys are looking at me expectantly. If nobody asks questions, I didn't bring anything. So, besides, there you go.
With 3D, when it asks what time the train stops and comes back, you would just set it equal to 0 because it's saying that.
When you say it, what is it?
The train.
How do you make the train equal 0?
The velocity.
There it is, okay. Because you have two main functions. You gotta make sure you're making the right one. Stops means speed is 0. Position isn't necessarily 0. Right? Okay.
So just set the velocity function.
Yeah, totally. It's all for t.
Yep.
One t is 0 because you know it's a position 0 at 0. The other one's gonna be, one is 0 because you know it starts off not moving, so people can get on the train. And the other one's gonna be wherever the hell it gets to before it turns back. Yeah. Yeah. Should I go? Alright. Where are you like that? Let's see. Well, I need the, how do you know this? Huh? No, they're not polynomials. So use what you see in the table you made. Right, okay. Okay, so you got the similar degrees, okay, good. And then, yeah, just don't forget to write your limit, or else this last stuff doesn't make sense. Why 1? Doesn't it work at like 1.7, 1.8, 1.9? Works all the way up to almost 2. But this question was about, what was this question about again? Where'd you go? Oh, where it's continuous. So it's discontinuous at 2, but it's continuous everywhere else around there, yes. So you should only, and so this shouldn't be including 2 because it's discontinuous at 2. So you should skip 2. Same way this says skip, well, actually now that I look at this, why is that a positive 6? So why is that what is, actually all of these need help. Okay. Yeah, so both of these. Something's going wrong. I think you're looking at like points instead of intervals. So what does this terminology imply? As both sides approach -6, what does that mean?
Left and right.
But what does that mean? What major calculus word that relates to the what of the function? Limit, yeah. So continuity, the definition is the limit's got to equal the function value. So I want you to show me where that breaks down. Does the limit exist? Yes.
Yeah.
What about the function value there? Show me that they're not equal to each other. That would mean discontinuity. Okay, because I get that. Function value, I'm not asking about the function value.
Like on some of these.
This one, number 4, yeah. Whole usually means the limit is this, but the function value is different. I don't know. That could be, but the main thing here is they're saying any function with a whole is discontinuous because the limit does not exist. So obviously that's a error. Could the limit not exist? Yeah. But you started talking about what happens most often, but you didn't really keep up with that. So this needs some work. Are you guys waiting for the same kind of thing, or what's up? Yeah. This is a very exciting part of this video.